Hello everyone, welcome back to Aided Learning. My name is Hanif Mohammed, CEO here at Asian Institute of Design. Some ground rules before we start. Kindly use the Q&A box for all the questions directed towards the speaker. The moderator would take it up with the speaker. In case you lose the line, please use the same link to come back in. For whatever reason you're not able to come back in, we are streaming live on YouTube, and then the recorded version will be also sent to your inbox. Asian Institute of Design is a progressive higher education institution since 2007. We are an affiliated college under the Bangalore North University, offering undergraduate and professional diploma in art design and technology. We started as the first dedicated gaming institute in India, then known as Asian Institute of Gaming and Animation. We've been churning out professionals for the AVGC, that's the animation, visual effects, gaming and comics industry and design. Our alumni have been contributing to leading blockbuster movies, part of Oscar-winning teams like Jungle Book, carries in movies like Godzilla, Avengers, most of the recent big titles as well. Alumni have been part of game development teams like games like GTA 5, Red Dead Redemption, Call of Duty, and so on. Alumni working in studios across the world, Canada, Finland, Singapore, Malaysia, and all the prominent studios in India as well. We have students from across India. International students come from Korea, Japan, Russia, Netherlands, and many more. AID Arts at faculty offers programs in gaming and animation. We'll be introducing our VFX programs this year. Our design faculty offers programs in communication design, UI, UX, and we will be offering spatial design from this year. Our technology faculty offers programs in ML and AI, game programming. We'll be introducing more emerging technology programs as well. Our programs are both online and in campus as well. We are a fine blend between industry and academia. All our faculty come from industry, again, who have worked in studios like DreamWorks or Luxia, Eccentrics, and so on. Being part of a few European Union funded projects under the Erasmus+, the projects were called MILIS, ECOMB, which are capacity building projects. For more details on us, please log on to asianinstituteofdesign.in. You can also follow us on our social media handles. Aided Learning, we've been conducting webinars on different topics, various different industries, and hence we found that the academy and industries are more than eager to disseminate the ideas and doubts with all the seekers. Aided Learning is all about aiding this progress, which blurs the difference between teaching and learning and creating common concerns globally, where knowledge becomes transparent and easily accessible. Asian Institute of Design, which is in its progressive approach, intends to connect reputed education institutions and industry experts worldwide to create an open forum to achieve a common and accessible knowledge pool. Aided Learning series will hold webinars, conclaves, and various other forms of knowledge sharing, making merit expertise with a concept of knowledge for everyone across the globe. This particular webinar is supported by Middle East College, Asian Institute of Design and supported by Global Observatory Spain, Smart Knowledge Alliance India and GCC, the Royal Institute of Technology, KTH Sweden, IIT Madras, and a project called Diesel. Diesel is a capacity building project in higher education. Diesel is nothing but developing Indian educational and skill strategies in e-learning. Diesel, the project focuses entirely on skilling and reskilling courses, packages optimized to need of technical staff or engineers for enterprise in specific industrial sectors. Aims in enhancing access to higher quality of e-learning material for skilling and reskilling of technical and non-technical persons, targeted industries such as automotive, construction, energy, IT, and IT industry. Project focuses on European higher education institutions, cooperation with higher education institutions in India, helping fill the skilling and reskilling needs of India. Main purpose of Diesel is to strengthening of relationship between higher education and wider economic and social environment. The main the aim of diesel being to modernize, increase access to internationalize the higher education, improve quality and higher education in alignment with labor market, increase cooperation between EU to promote people-to-people contacts, intercultural awareness and understanding. The partners in this project from the Indian side are Asian Institute of Design, Indian Institute of Science, Bangalore, Indian Institute of Technology, Madras, Symbiosis International University, Pune, Amrita Vishwavidyapeetham University. From the European side, we have Oberoi, Spain, we have the Royal Institute of Technology, KTH, Sweden, TU Berlin, or the University of Technology University, Berlin, and University of Lisbon, Portugal. With no further ado, let me introduce our moderator today, Dr. Kiran. Dr. Kiran is the Dean of Middle East College, which is the largest higher education institution in Sultanate of Oman. He's a key advisor to Asian Institute of Design. He's been associated with us since inception in 2007. He holds a PhD from London School of Economics and Political Science, UK, MPhil from Jawaharlal Nehru University. He brings a vast experience from his key roles as a national and international level in areas relating to higher education management, teaching research, strategic policy development, quality assurance, social computing, governance reforms, e-governance, and ICT for development. Dr. Kiran has been part of governance body of M.Sc. He's been a key member of the and he is an external reviewer of with the Oman Authority of Academic Accreditation, that's the OAAA, since 2015. In his capacity as Dean of M.Sc, Dr. Kiran has chaired the Institutional Standard Assessment Panel to colleges and universities in Oman. He also holds vast experience in heading and implementing key governmental projects and e-governance and ICT in Kerala as well. More than personally, a friend, advisor, mentor, and many more. Yeah, I hand it over to Dr. Kiran from here on to introduce the speaker. Thank you. Enjoy the session.
Thank you very much, Hanif. Good morning, everybody. Very warm welcome to this webinar. Before I start, let me just introduce Middle East College for those of you who may not know about Middle East College. It is one of the leading higher education institutions in the Sultanate of Oman. In terms of student numbers, we are the biggest in terms of the private higher education institutions. We are accredited with the Oman Academic Accreditation Authority. We are housed within the Knowledge Oasis Muscat, which is the technology hub of the Sultanate of Oman. And we run undergraduate and postgraduate programs in engineering, technology, and business. We also have programs on machine learning and artificial intelligence. So there's a connection there as well. And we've been working with AID, it's a sister concern, and through that we have been associated with the external and the partners from Europe as well as in India. So it's a privilege to be part of the webinar, and I'd like to thank Hanif and the team at AID for organizing this, particularly because this is a very good example of how partnerships like the DCEL project provides opportunities beyond the specificities of that project to provide information and guidance for people beyond the scope of the project. So congratulations on that, and thank you very much. Thank you very much for this. Before we start the proceedings, we've got a small poll to find out who all are joining us today. It's a small poll. I request everybody to kindly answer this so that we understand the nature of the audience that we have. Okay, a few more seconds before we come up with the answers. Yeah, can we now have the answers, please? So we've got around 27% of the audience of students, 57% academics, tech enthusiasts 13%, and IT professionals 4%. That's a good mix. We have around 93% of our participants today from Asia, 2% from Europe. It's quite early there. We are likely that anybody would be there from North America at this point in time, given the timing. We have 1% from South America and 4% from Africa. 55% of the participants are from India, 39% from Oman, 1% from Sweden, 1% from Spain, and 6% from others. That's a very good, very good participation. Thank you very much, everybody. Once again, a very warm welcome to the webinar. As you know, this is about artificial intelligence. And artificial intelligence and machine learning and data sciences are the most popular concepts that people across the world are talking about these days, of course, apart from COVID-19. And as is the case with COVID-19, very few people know about the details. And most of what is discussed in popular media is puts even science fiction to shame. Yet we realize that there is a lot of potential. Is AI a new phenomenon? What are its historic roots? What are the possibilities in healthcare, in education, in smart cities? What are the technological challenges? What are the career opportunities? What are the ethical and legal implications? So there are a lot of things to actually know than just be led by the popular terminologies. Unfortunately, we have with us two of the leading experts with us today. I would like to welcome Professor Kale and Professor Ravindran. We'll start with a presentation by Professor Kale. And let me remind all of you that we will take up questions which are very specific to a presentation immediately after the presentation. And any general questions, we will leave it towards the end. And we will take up those questions with both the speakers towards the end. And before I invite Professor Kale, let me introduce Professor Kale to all of you. Professor Kale is a Professor Emeritus in Artificial Intelligence at KTH Royal Institute of Technology, Sweden. He's a Senior Academic Advisor for KTH Internationalization in the prioritized regions of India and Latin America. He has his PhD in Knowledge Representation and Artificial Intelligence in 1986. Professor Kale is a lead researcher and examined more than 30 PhD students in AI, ML, and knowledge representation, automated reasoning, as well as intelligent interfaces. He has 10 of his PhD students are already tenured professors. He's the chairman of the Swedish AI Society and is the honorary president of the society. Professor Kale was responsible for the development of the new KTH 5-year M.Sc program in Information Technology in 1999 and was its program chairman from 1999 to 2005. He was vice dean for the KTH ICT School and chairman of its graduate study and recruitment committees from 2005 to 2014. He was a designer of and director for the EIT Digital Pan-European Master School from 2011 to 2016. Professor Kale was the director for the KTH ICT Research Platform from 2009 to 2018. Professor Kale has been associated with India for a long time, for many years now, and very recently was responsible for the development and lecturing of a IIT Chennai NPTEL course in machine learning. It's my privilege to welcome you, Professor. We look forward to your presentation now.
Okay, thank you very much. Okay, good morning from Stockholm. Gustaf Jansson here. The topic today is why artificial intelligence is much more than machine learning. And the topic was inspired by the fact that today, whenever you read a newspaper, you look at TV, you enjoy interactive media, you cannot miss the term artificial intelligence. So it's a strong limelight. 30 years ago, very few people of the world's population really had heard about this topic. So actually, you can see all these phrases floating around where people are, or enterprises are claiming that their services, their products, their gadgets use AI, that these are AI powered in some sense. So the question, what does it really mean? I mean, because very seldom when you read this shallow texts, it's made clear exactly how artificial intelligence is applied. So the topics of today is to try to some extent to clarify that, and also say something on why there is such a strong limelight on this area at the moment. And first, I want to start to say that machine learning and artificial intelligence are not new tech topics that suddenly occurred from nowhere. Actually, artificial intelligence is a well-established academic discipline, and it's very clearly a true part of computer science, has been so for a long time. And machine learning actually is a subdiscipline of artificial intelligence with also a long history behind it. However, if we want to relate what's going on in applications with academic disciplines, it's not always easy because it's maybe a chasm between these. So many times, and also in this case, over time there has grown, I would say, a large number of intermediate abstractions. And on this slide, I call them categorization of intelligence system. So there are terms like speech engineering, expert systems, data mining, and so on. I'm not going to delve very much in that because my esteemed colleague from IIT Madras will talk more about these particular areas. But I just to mention here the distinction between the pretty simple structure of the academic disciplines and all these other terms that have been introduced to characterize various kinds of system. So the first thing I want to do then is try to relate this subdiscipline of artificial intelligence with one model, my model in this case, of what an intelligence system can be. So for me, an intelligence system needed to have three components. So an intelligence system, I would say also, when I say it, I more or less mean autonomous system, that this is a system that can act autonomously in some context. So the first component that is needed is to be able to model the world. Without a model, without representation, system building is very difficult. The next step is that the system must be able to perceive the environment, to collect data, to aggregate, to abstract, and to adapt based on these observations. And the third part is, of course, to draw conclusions from the situation you have and to act, but because without action, the other steps are no use. So all these things need to be there for me in a truly intelligent system. Obviously, it's the case today that many systems that claim that they use AI do not do all this. They maybe just do a corner, which is relevant and can be have a strong value. But I think it's important to observe that either you have the whole machinery or you have a part of it. And actually, as you can see in this picture, the terms used in artificial intelligence to refer to these three blocks in the middle are knowledge representation for modeling, machine learning for the middle block, automated reasoning for the last block. having said that, I will go back a little also to the age, I would say, or the history of this field. And actually, yeah, first of all, I want to say something that when I discuss here today, I need a simplified model for stating whether a system are inspired or use AI or not. And the simple model I used is inspired clearly by the general character of computer science, where an algorithm is a key topic. In a simplified way, you could say that computer science is characterized by a huge portfolio of algorithms. And being subdisciplines of computer science, artificial intelligence, machine learning, then are characterized by their portfolios of algorithms in turn. I also, for simplicity, I consider hardware as neutral and views the functionality of the system as primarily dependent on the software and indirectly then of the algorithm. So therefore, you can say that, I mean, one way of attacking the analysis of whether a system use AI is to really look for algorithms. So one system can use one algorithm in one corner, other system can use a huge set of various algorithms in this area. And this is, for me, a kind of concrete way of looking into systems and whether they really benefit from this area or not. So this area has a long history. Maybe some people would be astonished by this because many people think this is something new, but it's not that. So I will say something about the history in a few slides. And the first thing I want to mention is that for this area, it's a little special because it actually exists a program statement. And that program statement is from 1956. And many program statements that are old are often considered obsolete because they have aged. But for me, this statement is pretty good still. So I will read it because I think it's well formulated. So the program statement for artificial intelligence is as follows. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that the machine can be made to simulate it. An attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. And then there is a funny ending. They say, we think that a significant advance can be made in one or more of these problem areas if a carefully selected group of scientists work on it together. So, 64 years ago, people were very ambitious. They met, they made a statement, and they believed they could go a long way the same summer. And now, 64 years later, we know that we still have a long way to go to really develop this area. Also, I want to say that these people were not just speculating. They also did things already in the 50s. And I have two slides. I will not discuss all the details, but I think the main message for me is the following, that there were already ongoing work in artificial intelligence in the 50s where people really built something. People constructed new programming language, problem-solving engines. People, Oliver Selfridge, for example, already in the 50s started to work on image recognition, which is a very, very important area today. And so all these things were really there, not as advanced as today. A lot of things have happened technically, but if you look at the flavor of what is done, it's not very different from what we see today in this area. And the same for machine learning, that was also defined actually in the 50s by Arthur Samuel. Samuel built a checkers player program actually, and he wanted that checker player program to be able to improve. And what the improvement mechanisms he termed machine learning. And as you can see from the slides, many of the things that are in the focus today, like neural networks, for example, were very, very strong and early in the beginning. So there is a long history, and what happened in the beginning is, in my mind, absolutely not obsolete today. The flavor of what was going on then is also very characteristic of what's going on now. So I want to say also mention some of the reasons that, in my mind, are the arguments for the limelight on artificial intelligence today. And one thing that I think is very important is that a lot of things have happened in computer science, in information technology. Since 30 years back, if you compare 30 years back and now, the digitalization of the world is so different. And actually, I find that the impact of artificial intelligence have improved immensely, maybe not just because of itself, but because there is so much digital infrastructure to work on, to use. So this is one block of reasons. The other block is, of course, that there have been success stories. So certain algorithms from artificial intelligence and machine learning have really proved useful in a number of cases. And in the following two slides, I give you examples. I will not go through all these examples because in the interest of time, but I will mention a few things with respect to the increased infrastructure. As you understand, a large fraction of the global population today have access to powerful digital devices. That was not the case 30 years ago at all. And of course, then they have the possibility to run so-called AI-powered system on these devices. And also we have this technical platforms that are the digital infrastructure, cyber physical systems, Internet of Things, cloud computing, and so on. And using an analogy, I would say that, you know, a body needs a brain. 30, 40 years, the body was weak because the digital infrastructure was weak. Today it's very strong. So today there is a strong body for the AI algorithms to work on, which of course increase the impact. Also the access to data, it's much better. And also there have been developed over time special processing units that facilitates the power of these things. Also software platforms that make practical development of life work easier is there now, which they was not there 30 years ago. So this is more the infrastructure part. With respect to the success part, I would say that it's clearly so that one area is very important in my mind for the success, and that's image recognition. So image and even video, moving images, video recognition has really created a lot of successful progress and successful application. Also speech recognition, I would say, is important. And I would say maybe to choose one area that seems to have created many good applications is healthcare. But of course, there are other areas too. An area where you probably can see the most coherent, kind of complete intelligence systems today and the years to come is, of course, the autonomous vehicles, where still image recognition is an important part, because many times when you read about autonomous vehicles and the issues there, the discussion is more about understanding the world around the vehicle than the problem of controlling the vehicle. Controlling the vehicle seems to be more or less solved, but perceiving the world around the vehicle is still an important issue. So conclusions. Actually, research and applications in this area, in the broad sense, has grown and developed organically over 60 years. No big, jumps. Steady progress. Currently, a majority of the claims so-called artificial intelligence powered system can exhibit only application on machine learning. So machine learning today dominates a lot. in my view, when we look at applications. And even so, for machine learning, it's not machine learning in a very broad sense. It's specifically machine learning applied to image, speech, and text processing, and also rather that it's a few algorithms that have been the forerunners here and have created the success. So the bottom line is that there are successes, but many other subdisciplines of artificial intelligence and many machine learning algorithms still awaits a wide applications. So thank you.
Thank you very much, Professor. I've got one or two questions that I'd like to raise with you. One is, how far away are we from the how far away are we from the general artificial intelligence coming into practice?
I mean, theoretically, I think things has advanced. So I mean, it's pretty likely that if that was the purpose, if that was the main focus, you could probably create something that is fairly generally intelligent. But in my mind, the focus is not there. The focus is on each little corner. I mean, each little application. And I think the commercial focus absolutely is in the corners. I think what's happening in my mind now is that this area improves by gradual improvements in hundreds and thousands of corners. And I mean, you can look at anything. You can look at the lawn mower. You can look at the vacuum cleaner. Every model every year get a little smarter, a little better, a little more able to understand what it's really doing, actually, rather than mechanically moving around with simple restrictions. So in my mind, what we see is a very complex phenomena where things improve in corners. Of course, there is an issue there because if we looked at one monolithic system, it would be easier to understand and control what it's really doing. But we have this myriad of developments all over the place. It's not so easy for anybody to have a grasp of what's really going on, and the kind of total system picture is not simple to grasp at the moment, I would say.
Thank you. I mean, just one more question before we move on. Are there some new research to look for regarding how much training is overtraining when it comes to machine learning?
Yes, I mean, I think machine learning is become pretty good at estimating the amount of training needed. I mean, of course, there can be theoretically there can be overtraining that is negative to the system, but in many cases also, I mean, it's a lot of effort of training. So economically, you should try to be on the exactly right level of what is needed.
Thank you, Professor. I mean, there are a few more questions, but we will take that up after Professor Ravindran's presentation. It's my pleasure to now introduce Professor B. Ravindran, who heads the Robert Bosch Center for Data Science and Artificial Intelligence and the Mindtree Faculty Fellow and Professor in the Department of Computer Science and Engineering at IIT Chennai. He's a PhD from the University of Massachusetts and his master's degree from Indian Institute of Science, Bangalore. He has visiting positions at the Indian Institute of Science, Bangalore and University of Technology in Sydney. He has 2 decades of research experience in artificial intelligence, machine learning, and specifically reinforcement learning. Professor Ravindran has been advising governments on several initiatives related to AI and data science. He's one of the founding executive committee members of the Indian chapter of ACM SIG KDG and is currently serving as the president of the chapter. Professor Ravindran was recognized in 2020 as a senior member of the Association for Advancement of AI and for his long-standing contribution to AI. He has published over 100 papers in journals and conferences, including premier venues such as the ICML, AAAI, IJCAI, ICLR, NEUR-IPS, and AMAS. He has been collaborating with industrial research labs such as Google Research, Intel Research, Ericsson R&D, TCS, Robert Bosch, KLA Tinker, Applied Materials, GE, Adobe Research, IBM India Research Labs, Yahoo Labs, and General Motors. And needless to say, he's quoted in top publications such as MIT Technology Review, Harvard Business Review, and Forbes India. Once again, a very warm welcome, Professor, and over to you.
Thank you. Thank you, Dr. Kiran, for the rather generous introduction. So I'm just going to share my screen. Give me one sec. Okay. Is my slides visible?
It is.
Oh, great. So, yeah. So, good morning, everyone. And really early morning to the person who is joining from South America. And I'm just setting my controls. Thank you. Yeah, so I'm going to really take off from where Professor Jansson left and talk a little bit more about why AI is much more than ML. And you know, you will find similar themes, in fact, the same themes echoed in both our talks, right? So to start off with, you know, AI is not this, right? So whenever we talk about AI, people either think of it as, you know, the guys going to take over the world and kill all the humans, or they talk about it as if it's a magic bullet that can solve all their problems. And as you know very well from the previous talk, AI is nothing but a piece of software. There is some collection of algorithms behind it. There is programming, you know, there is debugging, there is a computer that runs it, right? And just like any other software running on a computer, you can always pull the plug, and that's the end of it, right? So AI is not magic, AI is not evil. And it's just like any other technology, it has a collection of well-defined solution methodologies that go along with AI. And depending on how you use it, you get AI-enabled applications or not. So it's just to take the mystique away from AI, right? But if it is just another, you know, set of algorithms, right? So people have been doing algorithms for a long time. So why should you care about AI now? So it's because AI is really everywhere. Right? So if you go on Google and you fire a search query, I mean, most of the results that you see there are certainly informed by some form of AI, especially when you look at these kinds of text boxes, right? And these are information that is automatically extracted from possibly a Wikipedia page or UNICEF's homepage, and then are displayed to you. And this is done using AI techniques, right? Or if you go to social media, say you go to Facebook, you know, you upload a photo and then all the faces get tagged, or you know, you get friend suggestions from Facebook or LinkedIn and so on and so forth. And all of these are essentially, again, driven by AI, right? Looking at Google Maps, and just giving you examples of how AI is pervading all aspects of life that you have. You might not even realize that when you're using some of these tools, even when you're placing an order on, say, Flipkart or Amazon, right? That is the AI running in the background to figure out, you know, how soon they can give it to you, right? And how's the best way to deliver it to your house, and so on and so forth, right? And of course, almost every advertisement you see when you go online is selected for you by some form of artificial intelligence. And it's not just the online life or anything that you use with an app that is getting affected, but AI is everywhere, right? So I jokingly say that the kids nowadays talk more often to AI, whether it's on the phone or Alexa, than they talk to other human beings. But there are more non-frivolous applications as well, like helping with you know, diagnosis in various radiology tests, as well as some of the really amazing results that have been coming out in ophthalmology recently. And all of these are driven by AI, right? And but just want to reiterate what Professor Jansson said in the previous talk, right? Even though I call them successful applications of AI and AI is everywhere, in reality, they are successful applications of one subfield of AI, which is machine learning. Right? So all of these things that you saw, all the big things I showed you, all of these are actually driven by recent advances in the subfield of machine learning. Right? So does this mean that AI is machine learning? At least the AI that succeeds is machine learning? Well, let's step back and look at some things, right? So AI hype is not new. So here is a slightly dated article, right? The Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. Okay. So how far back do you think this was? Right? Almost back to the beginnings of AI, right? That's an article from 1958. If you remember, so 1956, the Dartmouth AI conference was where they initially even coined the word AI. And this is an article from 1958. And curiously, this is an article about a machine learning system, not an AI system in general, but about a very specific machine learning system called the perceptron. So AI hype is not new. It's been around for a while. At the same time, AI success is also not new. And I'm talking about real AI success. I'm not talking about hype here, right? So some of you might remember, at least a slightly elder people in the audience, might remember there's this huge news story about this computer called Deep Blue beating Garry Kasparov in chess. This is back in 1997, right? And so these are some of the things that people said back then. You know, Garry Kasparov said something like, "I could feel human level intelligence across the room," and then in a few years, even a single victory in a long series of games would be a triumph of human genius. So it has come to the point where computer chess, the really high-end computer chess programs, are very hard to beat, even for the top grandmasters in the world. Okay? And more importantly, this was a success story of AI that did not have any machine learning in it, right? So it's not like machine learning is the only thing that has led to non-trivial successes from AI technology. This is one case where people used well-informed search technologies, right, to build an AI that was extremely successful. So here is a more recent example where machine learning played a very small role, right? This was IBM's Watson engine. It took part in this quiz game called Jeopardy, where you're given an answer, the candidate has to come up with the question, right? And they took on the human champions of Jeopardy. And Ken Jennings was somebody, I forget, was a multi-time champion of the Jeopardy tournaments, and then he lost comprehensively to IBM Watson. And the main technology that was driving IBM Watson was recent advances in knowledge representation. Knowledge representation and reasoning, not necessarily machine learning. There was a small machine learning component to it, but that was not what caused it to be successful. Right? So AI is all around, right? So, but the recent successes alone are from machine learning. That doesn't mean AI is limited to that. We have had significant non-ML success stories from there. Right? And then this is something which Professor Jansson was alluding to. So I'm going to tell you that AI is not a single technology. Right? We already spoke about machine learning. I'll come back to machine learning in a bit. But then there are a whole slew of technologies, like when you want to do perception, right? So within perception, you have computer vision, which is a set of techniques or algorithms that you use for identifying objects in pictures. So it could be faces, or it could be animals, it could be tumors. I mean, all of these would come under computer vision. Right? And then you have speech processing, where you look at the spoken signals, right? And then you try to identify the speakers, identify words that are being spoken, identify sentences, pauses, silence, music, all of these. And then finally, you have natural language processing, which is the processing of written text, right? So you have to identify phrases, you have to identify syntax, the entities, and so on and so forth, right? And while there have been a lot of work done in the perception piece, right, the biggest successes of in the perception field have come from machine learning, right? And many of the success stories you saw in the previous set of slides I showed you were actually driven by the improvements that we are getting in this. And then you have this other side to perception, which is essentially cognition, which is understanding what you see, right, or what you hear, right? So it could be things like scene understanding. You want to describe what you see in a picture, not just identify, okay, that are these objects. Can you describe what is happening? Or can you describe a face, how it looks like? Right? And likewise, speech understanding and natural language understanding are all really hard problems. And AI has different sets of technologies that people are using in all of these fields, and it's still a work in progress. Even though machine learning has made some progress here, they're still struggling to achieve real success, right? And then you have reasoning and decision making, right? Automated reasoning part, and a lot of work has gone on in this space. You have a lot of theories of logic. You have things like decision theory. You have game theory, which tries to model rational behavior, and then you have this whole field of automated planning, which tries to take into account all the domain information you have and come up with coherent plans that lead to success, right? But then there is really no clear AI winner in this space. We're still struggling with simple problems, and there's been some success stories in games, like I showed you, Jeopardy and chess, and there have been a whole bunch of other games where machine learning has had big success recently. But still, AI has to come to a point where we are competitive with humans on general decision-making tasks. But in the popular imagination, this kind of decision-making, reasoning, and learning are what we consider hallmarks of intelligence. So if you go and tell people, "Oh, I have this AI, that marks faces on Facebook for you," sometimes people you can see the the light go off in their eyes. I'm not that excited about it. But then let's come to machine learning. So we have been talking about machine learning so far, right? And it gets the name machine learning because it's not really like how humans learn. Right? It's a different kind of learning paradigm, right? So to give you a very, very simple definition of what machine learning is, it's basically learning functions from just examples. So here is a example of that, right? So I give you a lot of images, right? And the images in each row correspond to a specific category. Right? So the images in the first row correspond to airplanes. The images in the second row correspond to automobiles. The third row, birds, and so on. Right? Then I'll give you these. These are the examples I give you. And then the machine learning algorithm processes these examples. And then it comes up with some kind of a structure. Right? Now, when you give it a new image that it hasn't seen before, it should tell you whether it is a bird or a dog or a cat automatically, without a human having to write down any rules or anything. Right? So that's essentially what machine learning is. I just give you examples, right? And I tell you what kind of functions to learn, and you learn those just from these examples, right? And this has led to a lot of success stories. So here is one from computer vision. The example I gave you in my previous slide comes from a competition called ImageNet, right? So there were 1,000 categories, not 1 or 2 or 10 like I showed you. There were 1,000 categories and millions of images. And so you have to go through these images and then figure out how to label an unseen image, right? Previously unseen image. So humans, it's not that trivial a task because humans make about 5% errors. So if you show them 100 images, they will probably get 95 categories correct, and maybe make errors on about 5 on average. And up until like 2011, you can see that the computer algorithms were making about 25% error. It's like basically they were getting 1 in 4 of these images wrong. Right? And in 2012, there's something called AlexNet that was introduced, and which kind of brought down the error from 25 to 15. You can see from 2010 to 11, there was like maybe a 3% reduction. But 2011 to 12, there was like a 10% reduction in error. That really got people's attention. And the technology that enabled is what we call deep learning. I'm not going to get into the technical aspects of what deep learning is, but just that it has had significant success. It's the technology that is driving the modern successful applications of AI. Right, and then every subsequent year, the ImageNet competition saw more and more complex, deep neural networks that were being employed up to the point where in 2015 we got down to 3.6% error, right, which is better than humans, and we keep improving that in subsequent years as well. So now we can do image categorization better than humans using an AI, and that's really something. Right? So even up as late as 2011, we were really struggling to match human performance. The same thing happened with speech, right? And about 2016 or so, for speech recognition, we beat human accuracy using deep networks, right? And that's just not these things, right? Even we can do some funky things like become an artist in some sense. And here is an example of giving the AI a doodle like this, right? So just like scribble something, and then the AI outputs a Monet. Right? So that's the kind of thing. And it was again trained using the similar kind of example-based learning that I was telling you earlier. And it can do various kinds of things with it, right? So the current thinking in the AI community is all you need to succeed is large volumes of examples. You give enough examples. I can create an artist. I can create somebody who's great at, picking out phases and other things, right? And preferably we need all of this to be tagged, but there are now techniques that allow that work even if a small fraction of the images or have the categories assigned already. And some problems you don't even need examples. You just need a simulation model if you want to learn to play games at a better than human level. I just need a simulation that allows me to play lots of games. So much of the investment that is happening nowadays, right? All the success stories that you see goes into generating the data. And you start hearing phrases like data is the new oil or data is the new water even, right? So that's how the field is right now, right? So, but wait, this is not really how we learn as humans, right? So we have teachers, we learn from peers, and there's a whole bunch of other things that we do, right? And we continue to learn, right? So we have examples from from completely different problem domains that we can use for learning in a new problem. And so this is not really how humans learn, right? And this causes some problems. So let's look at some caveats about using AI. Right? So all of this data-driven learning is fine when the going is good. So here is an example where an AI is trained, or a machine learning agent is trained to generate a description of what is there in the picture. Right? So sometimes it does great. If a person riding a motorcycle on a dirt road, a group of young people playing a game of frisbee, sometimes it's okay. Two dogs playing in the grass, and two hockey players are fighting over the puck. I always find that amazing. Of course, what are two hockey players going to fight over other than the puck? Even though it's not there in the scene, it manages to infer there should be a puck. So that's great. But then you get things like that. A skateboarder does a trick on a ramp. Well, obviously there is no skateboarder here. That's a cyclist, right? And a little girl in a pink hat is blowing bubbles. It's hallucinating the bubbles, right? There are no bubbles here. Right? So then you'd really like to know, why did the AI do that? Right? As long as the going is good, everybody is happy. But then when you start doing all these kinds of funky things, then you really need to know why, right? And it's crucial in many applications. So here are some examples of where AI has been used. In fact, in some cases, it has been discontinued even. So the first one is the Maryland court begin using artificial intelligence in bail decisions. They look at the previous history of behaviors and then decide whether somebody should get a bail or not. And they're not looking at your behavior. They're looking at somebody else's behavior and then trying to generalize. So they used the examples from previous behaviors, and it turns out that it became really biased, right? And it was denying bails to people who should have normally gotten bails, mainly because somebody else who conforms to the same demographic didn't behave properly in the past, right? So but you'd really like to know why bail was denied, right? Or how now AI is being used for deciding whether you should get a loan in the bank, right? Or how your loan should be managed, whether you should refinance, and all of those things are now being decided by AI. And again, you really like to know if somebody says you don't get a loan today, you like to know why, or what can I do to get the loan, right? So that explanation should be there. And where is AI in generating these kinds of explanations? Here is a simple to grasp setting. So here is an image, and it's labeled as having a dog and a cat in the image. You ask, hey, where is the dog? Why you call it a dog? And it's able to give some kind of an explanation. And then you ask it, hey, where is the cat? And it says, this is where the cat is. This is why I think there is a cat in the image. And it's really showing the hind legs of the cat, right? You would expect it to show something in the front. So what has basically happened is it's found some correlation between the pixels in the image and an answer. So visually it is easy to see, but it's exactly the same thing machine learning systems do when it's making decisions like bail, whether to grant bail or not, whether to give a loan or not. It's just finding these kinds of correlations, right? And they might not always be the explanations that you want to hear. But this is very critical in healthcare like situations, right? So like I said, deep learning has had great success in healthcare. And here is an example where it was great at finding diabetic retinopathy, right? So you ask the AI the question, why are you saying this patient has diabetic retinopathy? Then it's going to draw some circles on the image and say, hey, all of these things look like a person with diabetic retinopathy. Therefore, I think he has diabetic retinopathy. And then the doctor is going to say, no, that's just normal, no age-related degeneration, not necessarily diabetic retinopathy. Then the AI will come back and say, hey, you did not show that to me earlier. Right? In the examples that I saw, it's your fault, not mine. Right? AI doesn't say that yet. Okay, we don't have any advanced AI that can say that. All it can say is it just can, highlight these blobs and tell you, okay, that's why I classified this as having diabetic retinopathy. It can never tell you why do these blob imply that it has diabetic retinopathy. Right? So that kind of a knowledge is missing, right? And but you really have to think. I mean, is it your fault? I mean, it's that the AI is making these kinds of mistakes. Your fault meaning the person who designed the AI, not necessarily the doctor, right? So this leads us to the question: say, okay, if the AI is giving you all kinds of weird answers, right? It's looking at the tail and calling it a cat. So how robust is AI really? Right? Or machine learning, right? So I'm not talking about when they say AI now, it's basically machine learning. So how robust are these machine learning things here? Okay, let's look at a simple example. I have a bus. That's what the image looks like. And the AI says it's a school bus. They're all good. Now I add some noise to it, right? And you can see the image, right? What do you think it is? Right? Of course, there's not a poll that you can't answer there, but you think it's a school bus. Right? You know it's a school bus. Humans are great, but the AI thinks it's an ostrich. Ouch! And this was reasonably state of the art, right? I mean, even today you can construct examples that fool the best image labeling or image recognition engine. Right? Thinks it's an ostrich. So is that one-off case? You can design things like this all the time. So look at that. So we have a panda. I add some noise to it. Now it becomes a gibbon. So the school bus became an ostrich, but so did the dog. So I can add some noise to it, it becomes an ostrich. So you can actually attack a machine learning system by doing things that are so subtle that a human does not, figure out there's a change, right? But the AI gets completely fooled and misperceives the images, right? But these errors are not always due to attacks. Could be because the sample that we have picked, right? Has unidentified bias. So here's an example. This is a true example from an engine that was labeling things, and so you get it. Skyscrapers, great. So that's just a wing of an airplane. If you can't make it out, great. Cars, fantastic. Bikes, great. Oh, there's a graduation ceremony going on, fantastic. And look here, it says there are gorillas in the picture, right? So that has gone completely wrong. But not only did it go wrong, it did something that is really, really unacceptable, right? Calling a panda a gibbon is fine, but this is certainly not acceptable at all by any standards of ethics and morality and acceptability, right? So widespread use of AI, machine learning techniques, especially with this kind of guarantees that we can give on it, right? It gives rise to serious ethical questions. So there was this engine released called GPT-3, and which was able to generate very, very natural sounding text. I mean, you can just give it some hints and it can come up with an essay on those topics. Just take the hints and write an essay. I mean, there's like amazing feat of language generation. Right? But then the biggest problem was it was very, very biased. I mean, if you give it some kind of proficiency with criminal activities, right? It'll almost always say that it is African American male who was involved in the prostitution. And or if you give it something like the CEO of the company was, it'll complete it with man or white man. Right, so there are a whole bunch of different kinds of biases that went into this. And not only that, it started generating very abusive text also. Given the right kinds of hints, it was generating abusive text. So that's not acceptable, right? And similarly, this is an analysis of that the system that was being used by the courts in Maryland, and so it was denying bail to a lot of people, and it was actually getting it wrong, right? So historical data that we were using were actually making it copy the mistakes of the past. Right? And there was a more recent story where people arrested a guy in his lawn, right, just outside his house, because they thought he had robbed a convenience store. And it turned out that the AI had misidentified his face because the convenience store video was grainy. Right? But the police just arrested him, and actually they held him for more than 30 hours before they let him go. Right? And here's another example. There's this system recently that came out called Pulse that said that, oh, we can, give us a blurry image and we can convert it into, a good resolution image. And then people started analyzing it. And then here's a very famous example where things went wrong. They gave it a blurry image of Barack Obama and it created a white man. Right. So there is a whole bunch of things that can happen. This looks funny, but as long as it doesn't lead to an arrest, right? So when it starts doing things like this, then you have to really worry about where is AI taking us, right? So the fundamental problem with machine learning nowadays is it learns associations from data. There's no knowledge of the structure of the world, right? So we would think twice before saying something that has wheels is an ostrich, but the AI was happily labeling a school bus as an ostrich. And it doesn't have any knowledge of the processes of the world. The doctor could tell you why something that you see on an image is the reason for the diagnosis, not merely because others had it, right? So that's what literally the explanation that a machine learning system gives you, right? The machine learning system also doesn't have, any knowledge of the societal biases that are in there and trying to fix it. You can always say, hey, if the society is biased, if a human being is biased, that's how it is, right? So why do you expect the AI to be non-biased? That is a serious issue here, right? So if a human being is biased, it affects the decisions that he makes. If the AI is biased, because we are so keen on adapting this very widely in various other systems, that bias is going to become systematized, it's going to become institutionalized, and it's going to spread to many, many, many different places. So we have to be very careful about building AI systems that are bias free. Okay. So how do we fix machine learning? If this is what it's going to do, but it's got all these advantages, how do we fix it? We really need to go back to the drawing board and start thinking about integrating it with more classical AI. We talked about logic, representation, knowledge representation, reasoning, looking at causal structures, process models, and other things. We still are quite a ways off from getting these to work with the latest in the deep networks or the latest in machine learning. And that's a direction the community should be spending a lot of effort in, right? So AI has been undoubtedly successful, right? In very specific domains, we've gotten amazing. All the success stories I put it in the front, right? So in the very beginning of my talk, all those are real success stories, and we would like to continue using machine learning and AI there. But the current AI-based systems understanding of the world is about that of a 2-year-old, right? So we have a long way to human-like performance. But in the meanwhile, you have to handle AI machine learning with care, because it's more like this kid. It's not like any other 2-year-old. So if you misuse it, you can get into all kinds of troubles with ethical questions and erroneous decisions and so on and so forth. Summing up, we're closer than ever to functional AI. Again, as you could see that we thought that in the 1950s itself, right? But importantly, it's affecting many aspects of everyday life. So many success stories, right? And that AI is here to stay because lawyers and lawmakers are getting into AI. You hear all chief ministers and ministers talking about AI now, heads of states, right? For me, the biggest danger from AI or machine learning is humans rushing to market before the technology is ready, like they did with the bail system, right? So there was a commercial system that people were using, and then they figured out, okay, maybe we shouldn't have, right? So the discussions we need now is on regulations of AI and machine learning, and was it really your fault? Whose fault was it? So that's basically the direction we have to go. So some people want to know more about AI or some things. So the one on the left, we are professors, right? So we have to give you textbooks to read. So the one on the left is the kind of the quote unquote Bible of AI. It's very comprehensive. This is Russell and Novick's textbook on AI, but the other 4 suggestions are more fun stuff to read. And so thank you. And so we have this center at IIT Madras, and I'm not going to say more about it. You can look us up online or on social media. Thank you.
Thank you very much, Professor, for that interesting presentation. We have a couple of questions to both of you, and I'm going to kind of classify them under, for example, questions which academics have asked or teachers have asked, and the other is a set of questions from students. And let me take the question from the students, not from one person, from multiple people. But the question is, will AI disrupt the job market of current IT industry, especially who's working in the service-based industry? And how do we, what are the kind of skills that they should get in that new market?
Sorry, Dr. Kiran, I lost you for a bit. I mean,
sorry. The question is, it's a few students asking this question regarding, will AI disrupt the job market of current IT industry, and what are the kind of skills that they should have in the future? So Kali as well.
Okay. Do you want to start?
Sorry,
I mean, if
today any kind of engineering need more of digitalization competence than historically, and we still, I think, even at my university, we are still conservative. So we look at the technical areas side by side, and it's not always so that there is enough courses in digitalization in these other technical sectors. So I would say that you're a student and you believe you don't get enough knowledge on like computer science, digitalization in general. It's wise to take some more courses on a voluntary basis than is mandatory. And then, of course, gradually also, like on the top level now, I mean, for example, in general knowledge about data science, which is, we have talked about machine learning, but machine learning comes from AI, but it's part of the portfolio of competencies in data science in general. And I think also more and more engineers would fare well, also be a little more familiar with data science techniques. So I wouldn't say students today, in order to get a job, need to know everything about AI. Even I think it would be great if AI in general is kind of spreading. So first step, more competence on digitalization, and then probably a little more knowledge about data science and so on. So that is my advice, actually, rather than. Oh, okay. Please, Professor.
Yeah, okay. So my take on this is, so I completely agree. I mean, AI is a IT-driven technology, right? So, but more and more, so I have been advocating that everybody should know AI. Not you don't have to become an AI developer, right? So, but you should know how these technologies is going to impact your life. I mean, like everybody has some rough idea of what they can do with a computer in their domain, right? So, I mean, even if you're like a lawyer or an accountant or a doctor or whatever profession you are, now you know how computers are going to help you. Right? And there's this other set of technologies that are coming out, that's AI, and you should know how AI is going to help you. And AI is really a long way off from completely replacing humans in many of these disciplines. Right? There are a few success stories, and there are things like Alexa and Google Home, right, which are not really replacing humans. They're completely new kinds of job, quote unquote, application that we never envisage humans filling in. Right? There are a few things where it's going to be more efficient than throwing warm bodies at it to try to automate it through AI. That's the case with any kind of new technology that's going to come in. When computers came in, they replaced a bunch of people. So, or how many of us, and in India, we were all used to, while growing up, we were all used to seeing STD booths all around, right? So how many STD booths do you see now? And how many telephone booths do you see now? So there are things that are going to become redundant because new technologies become available. But at the same time, there are a whole slew of things that are going to open up. When mobile phones came and got rid of landline for telephones, right? And all these booths and other things went away. Did we ever think there are going to be Swiggy delivery people, like food delivery guys? This we're going to roam around that's enabled completely through smartphones. So similarly, there's going to be a shift in the kind of job profiles you're going to look at. Yeah, go ahead. Yeah.
May I have a last comment? And I also think it's not a binary thing. I don't believe so much as people will be obsolete and there are no jobs at all. But it's more subtle. It's more that all kinds of jobs will change in character. So you have to look at what's going on in a shop. How do the employees in a shop act? What do they have to do? And like 20 years ago, these maybe were the priorities. Today, everything works in a different, you have more machines, you have more technology even in a shop. So therefore, working in a shop is a different job than it used to be. And if you work in a big store warehouse, in a storehouse today, there are a lot of automation. There are still a lot of people, but these people do other things that they used to do 20 years. So I think one have to look at each sector by sector and understand the changes this is going on. And if you are, as a potential employee have a good feeling for what the change has been, then you are more likely to be employed than if you come and know nothing, about this.
And that's exactly why I'm saying that everyone should know what the impact of AI would be on their profession. So that's something that we should really start training them to. But yeah, jobs will change in character, right? Humans are not going to become redundant, right? And if you ask me what are the skills that are needed, right? So not everybody needs to know computer programming, right? It's not like you have to be an AI developer to be employed in the new AI world. You should just be able to use AI in an appropriate way, and there'll be tools that are going to enable you to do that, right? So then you just use the tools. Just like you don't have to know how to write code in C or Python to use a computer. They're going to be the equivalent of spreadsheets and word processing documents that are going to come up, which is going to help you use AI and do your job more effectively.
Right. I mean, you're talking
we
about.
We will let you go to the next question. Sorry.
It's okay. I mean, it's kind of connected in the sense that you're talking about the implication in different sectors. And the first question was from students, and the question from faculty members is, can artificial intelligence replace teachers? So the question is more in terms of, what is the implication on the education sector? Replacing, well, let's hear the experts.
I think you should also opine about this, Dr. Kiran, because you are seeing it also from the academician's point of view, right? So.
Yes. No, it's quite clear from your presentation that something like that is going to happen perhaps in a long time from now. They're not going to replace, but it's I think about how far these technologies can help the domain experts, including faculty members, to use these technologies for engaging with students and making the student learning better. So that's quite obvious. But what are the implications for the education sector? Would you like to highlight any particular set of things which will be, as you're looking at in terms of implications of particular cases?
First of all, I think my answer is the same. So one have to go, not just talk about AI here, you have to talk about digitalization. So of course, digitalization, online learning, these kind of things will change the teacher role. The teacher role will not be the same in 10 years that it used to be. And of course, some teachers would consider that a benefit, it's a good thing. Other teachers are afraid because they don't want to change. They are happy with the role they have and want to keep it. I don't think it will be kept. I think you have to act differently. And to some degree, it's a challenge because in my mind, it will be somehow more challenging to be a teacher because what's easiest to get rid of or automate from the teacher job is the boring things, the standard things, saying the same things all over again in a lecture. What the teacher probably need to focus is on the coaching side, but to really look at the individual's problem, and which of course is more challenging because you cannot just have your standard knowledge and apply it all over again. You have to be very, very open to every student's special needs, because all the basic things can be probably solved pretty automatically. There's so much online material that will exist in 10 years. So many standard lectures can be done that way. However, there's still needed this coaching part. That's extremely important in my mind, and it will still be there. So it's it's related. And AI, I mean, it's also this add-on. So for example, in online learning, you have a growing field of learning analytics. I mean, so of course, in an online learning system, you can do more and more sophisticated analysis of the data from the learning process and use that to improve the process. So there is an AI corner also here that is also growing with the purpose of making the system more useful, of course, hopefully, and better.
Yeah, so I completely agree. So even now it has already started changing, right? So when I lecture in my classes, I have to tell them, hey, by the way, before you start believing Wikipedia over me for this topic, there are errors in Wikipedia, right? I mean, so I have to actually look at what are the popular resources that the students see. In fact, there are some lectures where I have given articles written on Quora as additional material for them to look at, right? So, I mean, there is abundant of material out there, right? And so the role of a teacher has to change. But then there's a whole bunch of things, right? In fact, at least from an Indian context, the role of a teacher for me is not just go and just talk about subjects, right? So if I see a student sitting bored in my class, I have to take a call whether he's bored because he's finding the subject too hard or whether he's finding it too easy. Right? And I've seen both extremes, right? So people who are completely tuned out because they can't follow what is going on. So you really have to catch him, give him additional, help and things like that. Or if somebody is looking bored because he knows what is going on, then you kind of encourage him, try get him to contribute to the class. And things. So these are all these so much more human face to teaching, right? And in the Indian context, we have a huge scope, and I'm pretty sure it is true in most of the other third world countries as well. We have a huge scope for online learning, mainly because there are just not enough good teachers. I mean, I'm not talking about college, right? I'm talking starting from K to 12, right? From the kindergarten onwards, we don't have enough teachers. There are schools, even in my state, which is supposed to be one of the more, better, more advanced states in the country. There are schools in villages where there's a single teacher teaching like 5 grades, all subjects. Right? So how do you?
Yeah.
So you have to do something to augment that, right? So
I completely agree. I think one role this system can have is to maybe democratize, because the quality is very different across different parts of society and different countries. Some students get fantastic teaching education, others get very bad because this is a resource problem, and so if you can level it out and see to that you spread quality by using technology, more people can get an adequate level rather than a bad level.
Exactly. And the technology that we're talking about here is actually not AI. Okay, it's just the internet.
No, AI is just a corner still in the whole picture. I mean.
Yes.
Yeah.
Thank you, Professor. Thank you. I mean, I'm trying to find themes in the question. The other set of questions are regarding what is the recent advancements in the area of AI and ML, and what is the trend that you're seeing as we move forward?
I think if I just comment, Professor Ravindran talked somewhat of that. I think one research issue is this explanation power, that for machine learning, it's not enough to just be pattern matching. You need to, in the long run, being able to explain what you learned. So this was mentioned already by my colleague, and I think it's very important part. I also think the other thing you mentioned, Professor Ravindran, which touched what I said, is that a constructive combination of machine learning, state of the art, with the other parts of AI, with decision-making reasoning, with also looking at various kinds of knowledge representation, causal reasoning, and so on, that would make, I'm not sure how strong that stream is, but I mean, it would be great if that part also could grow now, in my mind. So those are 2 examples.
Yeah, I mean, so these are certainly for in fact, the explanation part is very, very active now, primarily because it is starting to limit the applicability of AI, the commercialization of AI. So people are not happy to put things, even though the AI gives very good performance, they're not happy to put it out into the field just because of this non-explainability part. I think in Europe, you have the regulations that say that if you deny somebody a loan, you have to tell them what is the redressal mechanism. That's what you should do so that you can actually get the loan. And if I'm using a machine learning system to make that decision, I can't, because it doesn't give me a redressal mechanism yet. Right? So it's kind of limiting the applicability. So as soon as you start hitting people where it matters in the wallet, right? So a lot of research now is happening in companies in order to come up with something that's more explainable. The other part of it, right, where there is integration of knowledge, representation, reasoning, and so on and so forth, is largely driven by academic research yet, right? Even though there is a strong stream of research there, but it's still driven more by academic concerns. And I believe that once we start showing the value of knowledge representation for explainability, right, I think that will also pick up. Right? So these are two areas that are very hot. And the third area that's now becoming, people are being forced to look at is the whole ethical aspects, like the biasedness of AI, right? So how can I make AI unbiased, even though the training data is biased? It's like, in fact, at the beginning, I used to think that this is asking too much of AI. You're asking AI to be superhuman, because humans are biased, but you give AI a biased data, you expect it to become unbiased. And recently, I read this article written by Professor Subbarao Kamambati, where he talks about why is it more dangerous for an AI to be biased than a human to be biased, and I completely buy that. And that's what the point I was making during my presentation. Yeah, so, sorry, Professor Khan.
But also, I also think it's related to the ethical things, but I also think the responsibility issues are growing. You mentioned that lawyers get interested. And they do. And I think this kind of system will take more and more small decisions. Maybe not the huge one, but smaller in various corners. Autonomous system will take decisions, and then it's difficult to judge responsibility even in the purely human world. I mean, if you go into a house and something happens to you, is it the shop owner? Is it the owner of the house? Who is responsible for the situation you ended up with? And of course, if you get automated components, I mean, like an autonomous vehicle, I mean, for example, who is to blame if something happens? I mean, this is a growing field, I think.
I think we should look at what other industries have done. For example, you take the automobile industry, right? So if you drive a car and you are in an accident, then you are liable, unless you can very clearly demonstrate that it was a failure of the car's components. Right, the similar kind of responsibility should now be on AI system. If you buy an AI system and then you use it after having signed off on all the disclaimers that the developer does, then you are responsible for this. Right? And
but there are two philosophies in autonomous cars, for example, as you know. I mean, there is the philosophy where you are still a driver, and the car helps you to drive, but you are still the responsible driver. And the other philosophy is there is no driver, there are only passengers. And if there are only passengers, is it the owner of the car? I mean, so all these issues.
Yeah, I agree. But the autonomous vehicle is still an equipment, right? You choose, somebody has bought it from the manufacturer and chose it to use it in a way. Right? Of course, if it's a Tesla, then Musk is responsible. But for everything else, then you have this gray area. But I agree. And there are a lot of work that is happening. In fact, I've been looking at some lines of research recently, which there's something called model cards that is coming out, which I'm really thrilled about. So I think that might be the way to get some kind of accountability into the AI industry.
Okay.
I think but the summary of it, it's a very active area of research.
Yeah, I mean, the legal systems are anywhere in the world is complex, which itself may require some superhuman intelligence to understand and tell us how things operate. Now, AI might add additional dimensions to it.
Yeah, there's a 20-year-old society in Europe called AI and Law. So it's called the Zurich Society, and people have been trying to use AI to improve untangle the legal web for a long time now. Yeah.
Okay, I'm conscious of timing. I'm going to ask one question to both of you, Professor. Professor Kalle, would you like to explain a little bit about the implication of these technologies on smart cities?
Okay, so first of all, a smart city then is a wide concept, and I mean, and there are different corners. But if you take a narrow definition of smart city, is essentially where cyber physical system dominate the picture. So this means that for the infrastructure, there are in principle a lot of digital components in all the infrastructure in this part, in a part of a city or in a whole city. And of course, I mean, there are many issues there. The control issue is one. I mean, you have a complex control of all this digital infrastructure, and AI can play a role in the optimization of the control. You also have a monitoring problem in a city. I mean, safety is an issue for many smart city problems. So monitoring what's going on, and also then as part of the monitoring, to analyze all the data that you collect and to actually find explanation for the processes. So these are two examples. I mean, and traffic is of course a big issue in a smart city. So I mean, it's not only an automated vehicle; it's rather that all components, the roads, and the infrastructure, like, have to communicate with the cars, and so it's the smartness of the car together with the smartness of the infrastructure that defines the success of the urban logistics. So I think there are many different corners. It's not that AI is good for smart city. It's that you have to break down what the smart city is in sub-functionalities. And then you could say maybe in this corner, you can use this kind of AI functionality to improve it, the behavior. Please, Professor.
I think that question was exclusively meant for you.
Okay.
But I agree with everything you said. Yeah.
Professor Ravindran, this is a question specifically in terms of India and where such technologies can help India. A few cases, a few ways in which such technologies can help India.
Okay, so one of the biggest places where this can really help India, right? So is in healthcare. So if you look at all the, quote unquote success stories that people have done with healthcare now, you look at breast cancer screening, imaging, and things like that. They're almost always at the tertiary care level, right? But what India really needs is more help in the primary care. Just like we don't have enough teachers, we don't have enough doctors, we don't have enough nurses, right? We don't have enough, medically trained professionals, anything, right? So at any level, at any scale, India is certainly lagging behind on that, right? So if you can build AI enabled technology, now I'm talking about AI, it's not just information technology, right? In education, you just need a way of getting, lectures to students, right? I mean, of course, you can do much better if you add AI on top of it, but that is something you can do. But here, just connecting a person remotely, the telemedicine part, right? Connecting a person at a remote place to a doctor is just not going to cut it because we don't have enough doctors who can look at those videos and diagnose. But you really need AI there, right? In order to, start giving reasonable primary care. It could be AI on a phone, right? That an untrained person, like an ASHA worker, can take with them to the villages when they go on camps, and then they can do some kind of preliminary diagnosis based on what's there in the phone. So this is one area that we can revolutionize Indian healthcare. Right? Get AI to the primary care. It's not leave it at the tertiary. Right? So this is one thing. And the second area that AI can really help is in agriculture. Right? And because the farming practices are pretty different in India than in the US, right? I mean, most farms in India are not even large enough for you to drive a tractor. So these are lands that are parceled into tiny bits and so on. So the way we do agriculture is very different, right, in India. And so we need to develop technologies for improving yield, and throughout the entire process, right, starting from analyzing soil fertility all the way to making sure what market would give you the best deal, right? So the entire agricultural supply chain can benefit a lot from AI technologies. I mean, these are two things that come off the top of my head. I mean, I can give you like a 2-hour talk on how AI can help in India, but these are two things which are unique in some sense to the Indian context, and the technologies that we build here would certainly go out and change a lot of Asian countries, African countries could certainly be developed from this, and I think we should invest a lot in this sector.
Right. Thank you very much.
Can I answer one question that I saw on the Q&A forum?
Yeah, please go ahead.
There was this question about, is AI leading to a new kind of arms race? And are we going to see, AI-enabled weapons and so on and so forth? We are already seeing this. These are called viruses, right? So there's the whole cybersecurity phase that is happening. The next war is going to be fought on the IT space, right? And if somebody is so far ahead of you that they can take out your entire IT infrastructure in your country, they win without firing a single bullet. So that is a place where AI is actually playing a lot of role now. So we have to have systems that quickly adapt to newer kinds of attacks and so on and so forth. Yeah. So, but yeah, there is going to be an arms race in AI, but not in the way you think. I did not necessarily put it on the next smart cruise missile. But yeah, just on your
okay. Thank you very much, Professor. And with that, we are coming to the end of the session today. Thank you very much for the wonderful presentation and interesting discussions that we had. I'm also very thankful because before the start of this session, I was wondering whether Hanif will replace me with a machine or a robot by the next webinar, but looks like I have got some more scope for at least for a few more years. So thank you for giving me that encouragement. Thank you very much, Professor. So thank you very much for all the participants. Yeah, please, Professor.
No, sorry. There have been a lot of questions about whether they can get my presentation or both of our presentations. I'm happy to share it with you. If there is a way you can put it online somewhere, they can access it.
We'll do that. Professor.
Yeah, no problem.
Both the presentations, we'll try and make it available to all the participants. Okay. And if there are other questions as well, we'll send that across to you. And try and get these answers on our net. Thank you very much. We have the next webinar coming up on the 25th of July, Saturday. It's on virtual production and the real world revolution. Once again, thank you all very much. Thank you to people across the world for joining us today. And thank you very much, Professor Ravindran and Professor Kelly. Thank you very much.
Thank you. Thank you.
Thank you.